Climate change, it's a phrase we hear all the time, right? But the details, well, they can feel a little overwhelming. So, what does it all actually mean? We've gone through the source material and boiled it all down into a clear set of slides to give you a simple, straightforward guide to one of the most important topics of our time. Let's dive in. So, right off the bat, let's be super clear about the stakes here. This isn't just some environmental buzzword. The source material calls it one of the most severe and urgent challenges humanity faces. And that kind of urgency is exactly why it's so important that we all understand the fundamentals. Okay, first things first. Let's get our terms straight, because you hear these two used interchangeably all the time. Climate change is the big picture. It's about the long-term shifts in weather patterns. Global warming, though, is more specific. It's that steady, persistent rise in the planet's overall temperature. Think of it this way. Global warming is a major symptom and a huge driver of climate change. So we've got the what. But how is this all happening? What's the engine running behind this whole thing? To get that, we need to look up, way up, into our atmosphere. At the very heart of this story is a totally natural process. It's called the greenhouse effect. Honestly, you can think of it like the planet's own thermostat, a beautifully tuned system that's kept Earth's climate stable and, livable for a very, very long time. And the key players in this system are something called greenhouse gases. See, our atmosphere acts like a protective layer, and certain gases in it work like a blanket, trapping just the right amount of heat from the sun. And that's a good thing, a really good thing. Without this natural effect, our planet would just be a frozen rock. Now, these are the main gases that make up that atmospheric blanket. You've got carbon dioxide, methane, nitrous oxide, and a few others. And while they all play a part, the one you hear about the most, for good reason, is carbon dioxide, or CO2. It is by far the biggest contributor to the extra warming we're seeing right now. This comparison is just fantastic for putting our own planet into perspective. On one side, you have Mars, not enough greenhouse gases, so it's freezing and lifeless. On the other end, you've got Venus, way too many, which created a runaway, scorching hothouse. And then there's Earth, right in that perfect Goldilocks zone. We're here because we have just the right amount of these gases. And here is the absolute crucial point. That balance is incredibly delicate. Get this, CO2 makes up only about 0.03% of our atmosphere. It's a tiny, tiny fraction, but its power to trap heat is so immense that even a small fractional increase can have enormous consequences for the entire planet. For centuries, that delicate balance held steady. But, pretty recently in the grand scheme of things, something changed. We started adding more greenhouse gases to the atmosphere, tipping the scales and essentially making that natural blanket thicker. So where are all these extra gases coming from? Well, the data's pretty clear. The overwhelming majority, we're talking around 75%, comes from burning fossil fuels for energy and for transportation. Things like agriculture and land use changes, like cutting down forests, make up most of the rest. This timeline really tells the story. For thousands of years, CO2 levels were just stable. Then the Industrial Revolution kicks in, and they start to climb. But look at this. The most alarming part is right here, around 1975, when the rate just explodes upward. A staggering 2/3 of all the warming has happened since that point. This isn't some slow, natural cycle. This is a massive acceleration happening in our lifetimes. Okay, so we've thickened the planet's blanket, and we've cranked up the thermostat. What does that actually mean for us here on the ground? Well, these consequences aren't theoretical anymore. We are seeing them play out all around us. If you take away just one single fact from this entire explainer, please make it this one. Look, the Earth has warmed up before. But in the past, a typical warming of about 5 degrees Celsius took 5,000 years. At our current rate, we are on pace to warm the planet up to 20 times faster. It is the sheer speed of this change that is so completely unprecedented and so dangerous. And this rapid warming is hitting the world's frozen places especially hard. We're seeing glaciers retreating basically everywhere, from the Alps to the Himalayas. The massive ice sheets in Greenland and Antarctica, they're losing billions of tons of ice. And huge areas of permafrost, ground that's been frozen solid for thousands of years, is now starting to thaw. So all this extra trapped heat, where is it actually going? The answer is just staggering. 90%, a full 90% of that extra heat has been absorbed by our oceans. They've been acting like a giant sponge, honestly, protecting the rest of the planet from warming even faster than it already is. But that kind of protection comes at a cost. See, as water gets warmer, it expands. That, plus all the water from melting glaciers, causes sea levels to rise, which is a direct threat to coastal communities. And warmer oceans also act like fuel for more powerful and more frequent extreme weather. We're talking more intense hurricanes, longer droughts, and more severe heat waves. So that's the science, and those are the consequences. The crucial question now becomes, where do we go from here? And this part isn't about doom and gloom. It's about understanding and ultimately about action. We have to be realistic here. This problem didn't just pop up overnight, and its effects aren't going to be reversed in a few weeks or months. It took decades of consistent action to get us here, and it's going to require a sustained, long-term effort to change our course. So the path forward really starts with two crucial first steps. The first one is what we're doing right now: awareness, simply understanding the risks. And the second is to start re-examining our own habits, especially around things like transportation and electricity, which we know are the biggest sources of emissions. And all of this leaves us with a really powerful final question. It is so easy to feel like this is just this massive global problem that's completely out of our control. But the data shows that it was our collective human choices that tipped the scales in one direction. And that means a collective shift in our choices has the power to start tipping them back. The question isn't if our choices matter anymore. It's how we'll choose to make them matter from this point on.